So now we are at next station. We have two instruments called PL and jewelry inspectors, the low-cost instruments designed for viewing fluorescence and phosphorescence on gems and diamonds. It's also possible to use our camera, our phone actually, to compare these reactions. Let's first check one round stone and look under long UV light first, and we will also use this program app called Geometrix. It's free on the Google Store or Apple Store for iPhone or Samsung like I have, and we will basically find this stone, and in this case you can see that it's weak red fluorescence. We can take the image, save it in a library, and compare to the short UV fluorescence that is much stronger, chalky green blue, and this is typical for stones that are not natural. In this case, this is a man-made glass, and we can compare these two images, play long UV, short UV next to each other, even stop it, save it in our Geometrix library for further reference, and even split the stone in half and compare. Long UV on the left is more weak red and short UV is much stronger, typical for imitation or man-made materials. We did all these images in our booklet that you have with Samsung or iPhone. We did together with John Chapman from Geometrix Australia, and you can see some of these stones here. This is synthetic color sapphire that is we make images, and we also did other techniques with cross-polarized filters and using spectroscope. So we have a quite big stone now, 10 karat emerald cut. It's purple, and we use bigger instrument with bigger opening that is designed for mounted stones and big stones. We can use the same steps. Long UV fluorescence always first. It's good to observe also with a naked eye, but it's even better, more safe to use a phone, because short UV could be dangerous for the eyes, but in our case it's protected by the glass, and it's not harmful. There's strong orange-red fluorescence on the long UV light. We can take image, save it, and short UV light will change now to SW. It's changing to more medium, chalky purple, greenish blue, and stones natural could also be color changed, but not with such a fluorescence. Usually it's much weaker red, and this is typical fluorescence of synthetic man-made color change sapphires. It's a first step. We can also look a stone on the microscope or with a loop. This one has a curved striae and other things to observe.